Okay, chapter 3. Now that we've taken a tour of our computer system, our big picture tour, and then we kind of had a really good understanding of what happened from the software perspective and from the hardware perspective of when we go from authoring a source code file to compiling it into machine code, into then launching it into the system and executing it, right? We examined the flow of a hello world program through both software and hardware. Then we moved to peer in and really zoom in to, in chapter 2, how we represented that data as binary representations. Now, let's move up a level. Let's move in chapter 3 to the machine level representation of our programs. And so this chapter should cover some concepts we've already seen inside of our tour and inside of our very first lab 0, our intro lab. So this will just bring us back. It should circle us back to those days where we were talking about some of those concepts that related to compiling and linking and assembling and executing. So our learning objectives here is we're going to learn how to read x86-64 machine code that's generated by a C compiler. So this might, and so correct me if I'm wrong, but I think up until now in your assembly class, you were reading and you were authoring assembly code that was written by people, right? The idea was, how can we use this as a language to craft software? Am I correct in that assumption? Most of what you were looking at was human authored? Yeah, so here, why it now becomes valuable to look at assembly is we're going to look at it from a different perspective. Because most often, the entity that generates assembly code is not people. It's typically automated tool sets, our tool chains, it's our compiler, right? And so we should be familiar at looking at assembly code that was generated by a machine that's been auto-generated. Okay, what are other learning objectives that we're going to cover over chapter 3? We're going to cover the basic instruction patterns that are generated for different control constructs, such as conditionals, loops, and switch statements. Now, again, we're not talking about the high-level representation. We're going to see how that creates patterns in its machine code and assembly representations. So you're going to see when a machine goes to convert or translate high-level code into our assembly code or our machine code, it's going to fill it with lots of things that's designed for the OS. So we want to identify when we look at that, oh, it's doing this for this reason. So we're going to look at those patterns that are generated based off of the tooling, based off of the auto-generated code. We'll cover the implementation of procedures, including stack allocation, register usage conventions, and parameter passing. This, I think, should probably be an overview for most of you, right? You probably covered this also inside of assembly. We'll cover the different data structures, such as structures, unions, and arrays that are allocated in access. We'll cover the instructions that implement both our integer and floating point arithmetic. We'll use the machine level view of programs as a way to understand common code security vulnerabilities, such as buffer overflow attacks, and steps that you as a programmer or the steps that a compiler or operating system can take to reduce these threats. And again, the motivation for this chapter is what we want to learn the concepts in this section to help us become better programmers. Because if you understand how programs are represented on the machine, you can benefit to make better decisions on how you implement. Okay. So again, the motivation behind these slides is to pull the content directly from the book in a way that covers it in a slightly different way. Has anyone actually started reading the book itself? Or has everyone really just been relying on the lectures for the most part? I will say, and I think I stated this earlier, this is a really well-crafted book for students to read. There are some books, such as your data structures book, which can be incredibly dense and packed with lots of math proofs that I feel are really classified as instructor-led textbooks, where you almost need to have an expert to be able to view the content and then produce the step-by-step explanations that gives a novice to give someone who is trying to learn the material an understanding of what is held inside of there. Now, that's one type of textbook. I'm pretty sure, if I remember correctly, that the data structures textbook, that's an instructor-led copy. This copy that we've selected here for systems is the student-led. The author has painstakingly really produced a lot of content that explains it in step-by-step ways in very common parlance, in very kind of common speech, so that it can be understood directly taking and reading from that. So because of that, what I try to do is supplement the explanations given in the book, which I could not recommend to you all enough that you should read if you have the time to, because it would just harden your knowledge that much more so, but also kind of feed into the book with the C code examples that we're looking at. So like, for instance, when the book gives a table, I'll create a C code that gives a larger view of the table. Okay, so that said, the topics in the book that we're going to look at are going to follow, or in the slide deck, are going to follow that of the book. So a valuable thing about machine level representation, and I don't normally like to do this. A lot of times, if possible, I like to abstract away the historical context because it's not really important for doing things. But machine code and assembly code are one of those rare instances. It's kind of valuable to have a small amount of historical context because so much about where we're currently at in our instruction set architecture inside of the set of keywords we have and the registers we have are based off of the prior states of what came before today. And so especially a lot of the naming conventions. So we'll take a brief historical journey to understand why we have registers that might be defined as AL and AH, or AX, or EAX, or what have you, right? So, and then from there, we'll take a look at the various programming codings that happen to represent our programs as machine code. Then we'll look at the data formats that are available to us at the machine level. And then we'll see how we can access our information from the machine. And then once we access the information, then we can start processing that information in interesting ways. Since everything's fundamentally numerical, we'll look at arithmetic and logical operations. So our logic gates. And then finally, we'll look at our control structures and our procedures, which is another name for what we call functions inside of our machine code and our assembly code. Then finally, we'll look at array allocation and access, and then the heterogeneous data structures, which I think we've already looked at somewhat in our C code example. So in those instances where the book starts to overlap with the essential C PDF that we read and that we covered in the beginning of the slides, we'll go very quickly, right? There's no point in repeating things we've spent entire lecture blocks kind of defining. And so once I get through this chapter, at least parts of the chapter here that we haven't covered in a prior lecture, what we'll start doing is walking through the bomb lab. Because what this chapter really motivates is being able to use a debugger to be able to identify code and to use it to debug, to find out what's to be able to step through code as it's actually running on the system. So I want to tether the theoretical concepts that we're doing in lecture to the practical concepts on how you actually use this in the real world. So we're gonna, after these next couple lectures where we go over this content, I want to step away and start doing more like lab-based workshops in our class. And then I might actually then, with that said, I might take and then flip the classroom, so to speak, where we might, for the next several lectures, do more lab work, practical lab work, and where I will encourage you to actually do the readings out of that textbook that I mentioned so that you can get the more general concepts that will govern the very particular applicable things we're doing in class. And that's what, so when I say flip the classroom, I'll have you learn from the book while we actually do things in our class hour. All right? Okay, so we'll have at least a deeper lecture on chapter 3. I don't think it's worth going any deeper than this because I only have 7 more minutes, so I might relinquish us a little early. I think I've set the stage for what we'll do in chapter 3. My goal is next week, already next week, next Monday. Wow. Okay, next Monday, I want to try to cover everything we need in chapter 3, if possible, and then start on Bomb Lab in class on Wednesday. Worst case scenario, we spend next week on chapter 3, and then we'll do Bomb Lab the week after. So it just depends on how quickly we can make it through that content. Excellent. With that said, we're done 7 minutes early today. Unless anyone has any questions. I do know someone wanted to speak to me after class, so just hang around if you wanted to do that. Yeah, so the question is, will it be similar to the machine code we saw in the intro lab? Yes, it should be.